Okay, so tonight we've got Nick Hewitt going to talk about nebulae, and Sean Reynolds is going to show some of his nebula images. Thank you very much, guys.
Okay, so I'm going to kick off. People hear me okay? Dave, tell me if you can't.
Yep, can hear you.
Good, right. Well, hi everybody. Getting increasingly familiar with you, and in some respect, not too familiar. And tonight, just want to introduce nebulae, as generally discussed. I'm a great fan of nebulae. I might be telling you how to suck eggs, though, because I know some of you image an awful lot better than I do. Sean and Rachel certainly, and others. So basically, this is an overview of what nebulae are. And I've got a little button here. So what are they? Well, the definitions really can be from the Latin. It could be either a mist or a fog, a cloud, thin film, or just something a bit obscure. Generally speaking, we think of it as being a cloud or something rather diffuse. But in astronomy, it's a cloud of gas and dust in space that we can either see as a bright area or sometimes an increasingly popular from the deep sky guys' point of view. We start seeing silhouettes of dark nebulosity against bright backgrounds. So let's have a little look. What do they basically mean? Well, with regards nebulae, there are 5 ages really, and with regards star ages, their nebulae are involved in all the processes. First and foremost, we have the raw materials that make the stars and therefore the galaxies, of course, and these are the dark nebulae. Then we have star birth within these dark nebulae that become excited, and we start seeing emission nebulosity, and obviously I'll talk about that in a little bit more detail. And then during the life of stars, we start seeing reflection nebulae. Reflection nebulae, some of the most beautiful of the nebulae, in my view. But then we get through the life of stars and we have the old age, we have planetary nebulae, which are also extremely beautiful. And then we have the relatively rare supernova remnants of star death, exploded stars. And these are all ways that the materials are processed within stars and got back into the interstellar medium. So really all ages of stars, there are nebulosity associated with it. Historically, it wasn't entirely clear what they were. When the first telescopes were pointed at the stars, some stars were obviously clusters, but there were fuzzy patches too. The faint fuzzies of people very famously describe them. Some were easily resolved. On the left here, you can see the Messier 35, lovely cluster in Gemini. But just below it in this image, there's a much more difficult cluster and in the past, they wouldn't have necessarily known that was a cluster of stars. But people did think that all the stars, all the nebulae could be broken down into stars and resolved if only the telescopes were big enough. And of course, as telescopes became larger and more sophisticated, the penny started to drop that there were differences. They weren't all stars. There were possibly other things. The middle image here is one of the nebulae named after Dave, the Eagle Nebula, Messier 16. And this starts showing that there is a cluster associated with this, which was easy enough for them to resolve, but there's this haze around it, which proved quite difficult to interpret. And then this right-hand image is that by Isaac Roberts, the pioneer astrophotographer from this country, who took this marvelous photograph back around the turn of the 19th to the 20th century of the Andromeda Galaxy. But even then, they didn't really know what the Andromeda Galaxy was. Many people, including Roberts, thought this was probably star formation with a planetary system forming in what we now know are the spiral arms of this galaxy. First person to really think in terms of nebulosity perhaps was Sir William Herschel, great observer, surveyor of the skies, and he thought this planetary nebula, NGC 1514 in Taurus, to be a singular phenomenon, and basically thought that the star and the nebulosity surrounding it was so likely to be intertwined that there was no chance that this was going to be further stars. This was going to be a star with gas around it. And of course, as spectroscopy and photography took over, we realized that there were lots and lots of different ways of interpreting the nebulae. Ultimately, only 100 years ago, as recently as that, the spiral nebulae, some thought they were in the Milky Way galaxy themselves, and it was Edwin Hubble 100 years ago, last April, that really ended the great debate. And he showed by finding Cepheid variables in the Andromeda galaxy that these were in fact remote star systems of their own. So these raw materials, they're basically molecular clouds. They're clouds of molecular hydrogen with a few other chemicals chucked in there for good measure. And of course, they're very, very thin. They're very much slightly denser than a vacuum. But because there's so much material, we can sometimes see these as they're in the background brightness of the stars in the Milky Way galaxy. You can see the silhouettes. Now, the one on the left here is best known as the Pipe Nebula. I'll use my cursor here just to show this is the bowl of the pipe and the stem of the pipe. But in fact, you can make out the dark horse, because here's his face and his mane and his front. I don't think they're paws, are they? Well, call them legs, front legs. And this, of course, was Saturn 3 years ago in this area. So these are dense by astronomical standards, but not by vacuum standards on Earth, dense areas which are so dense that basically the starlight from behind them can't get through, not easily anyway. And along these, the plane of the Milky Way galaxy, you can start seeing that there are other things going on. In the right-hand picture here, you can see some reddish areas, which are the emission nebulae, which I shall describe later. And you can see a few of those in this relatively wide picture taken from Arizona, or Utah, in fact. No, this was Utah, back in 1997. And you can see towards the bottom right is the Lagoon Nebula, slightly above it is the Trifid Nebula. Dave was absolutely right about the pronunciation, and I stand corrected. Thank you, Dave. And a bit further up, we have the Swan Nebula and the Eagle Nebula themselves. And of course, now we now know other spiral galaxies, and one of the important factors in knowing that that these galaxies were beyond our own galaxy was we could see that they had molecular material too. This is perhaps one of the best known, the Black Eye Galaxy, Messier 64, with its very, very prominent dark lane towards the, I'm not sure I can show that, yeah, just here. So we know that other galaxies have loads of dust and gas and molecular clouds, and they're generally confined to the plane of the Milky Way, and this is where we see them. The ones towards the center of the galaxy are really quite pronounced. The ones further north from our point of view, through Cygnus and into Cepheus, are somewhat less dramatic, but equally interesting. So the best known of these, of course, is the Horsehead Nebula itself. This almost iconic dark nebula, very, very beautiful. Part of Orion, just underneath the belt of Orion, and the little silhouette of this very dense material stands out remarkably well. And the close-up, more close-up of it shows a bit like a a chess knight, perhaps, the head of it, Barnard 33. There are lots of others available. This is one of my favorite regions. It's not easy to get at from this country. It's very low down in Ophiuchus, but this was taken with a remote facility down in Siding Spring, and I got this picture a few years back. But it shows the Snake Nebula, which I think we probably can work out which that one is. But centrally, there's this extremely dark nebula, which is Barnard 68, which is one of the most opaque dark nebulae, and it's relatively small, probably star forming. There are probably stars within there just being born, but they won't be super giant stars. They won't be very massive stars. They'll be stars a bit like the sun. So these are quite fun areas, and they're becoming much more commonly enjoyed by amateurs these days. Just wanted to briefly mention Bok globules. These are very small areas of dark nebulosity associated with emission nebulosity. They're probably a light year or two in size, and contain material that can make perhaps a couple of stars or possibly a small cluster of stars. This is the rosette in hydrogen alpha taken with my 70mm star wave a couple of years back. The actual, on cursor again, these are the Bok globules, these very tiny spots. They almost look like they're defects on the image, but they're not. And within those, this is the sort of thing that our sun may well have been born out of. So, star birth, the emission nebulae. Emission nebulosity, I'm afraid this is a very busy slide, and I don't intend to sort of read down that, but basically what happens is you have more massive stars, the hot O stars, the B-type stars, forming within a molecular cloud, but then will be hot enough for their ultraviolet to cause them to basically fluoresce, and they basically break down the neutral hydrogen to a proton and an electron, and they will then recombine, and as they recombine they emit a further photon. And in the case of the emission nebulosity, it's often in the red end of the spectrum. So the wavelengths of around about 656 nanometers comes out in ordinary photographs like the one I've taken of the rosette on the left here, as a red colour. Check that. So most of the emission nebulosity is basically fairly red, unless you do other things. And Sean's going to tell us about what you might do to those later in using other palettes. But this is basically a representation of the correct wavelength for red light. So the Orion Nebula, of course, is far and away the best known areas, the star birth region, 1600 light years from us, within the largest of the closest of the large giant molecular clouds to the sun. There are very much larger ones in other galaxies. The Tarantula Nebula is enormous, and the Triangulum Galaxy also has a very, very large emission nebulosity called NGC 404. But the Orion Nebula is something that everybody has a go at. And within this Orion Nebula, of course, we're starting to see stars being born. I always burn out the trapezium. One of these days, I will follow Dave's good example and learn how to not burn out the centre of the Orion Nebula. But at the moment, you have Fred, you've got the white area covering the trapezium. The image on the right here is taken with hydrogen alpha, and you can bring us out a lot more detail, really. People are now doing other narrow band imaging on the Orion Nebula and teasing out extraordinary detail. But I will have a go at that this winter with any luck. Now, these new stellar objects within these clouds actually then become reflection nebulae, and these are some of my sort of favorite area, really, the so-called variable nebulae. This is perhaps the best known of the lot. This is Hubble's Variable Nebula. And this is a reflection nebula. The star has not long been born. It's got a lot of material still around it. It has an accretion disk around the star itself, and it has an outflow both north and south, but we can only see the northern component of that fan shape. And this Tom Polakis animation, taken now 2 decades ago, shows that over a period of a couple of months or 3 months or so, how the nebula can change. And that's a whole new talk. But these new baby stars are of great interest. There aren't that many of them for the amateur, but they're fascinating. But these are, of course, reflection nebulae, and we're going to come on to those now. One of the other young objects is in this area on the left, which is Corona Australis. Sadly, an area we can't see from the UK, even with the trees cut down or houses bulldozed. We can't get to Corona Australis from anywhere in the UK. But it's a fascinating region. It's you can see in this image, there's a dark molecular cloud manoeuvring its way down to the lower left here. The little cometary nebula here is actually 2 young stellar objects, R and T Corona Australis, both variable stars. And of course, just as an added bonus, we have a lovely globular star cluster here too. These are reflection nebulae. They're fairly typical blue reflection nebulae, and I'll explain a bit about why they're blue in a moment. And probably even better known, well, a lot better known, is the Pleiades. Now, the reason for these both being reflection nebulae are different in some respects, in so much as the Corona Australis complex are basically being born out of the material of this cloud here. And so this is on the edge of a molecular cloud, and shows up quite nicely. But this reflection is actually nothing to do with this particular pair of stars. There's another pair of stars in here and a star up here which are causing the light to scatter. The Pleiades is different in so much as it was actually born probably 400,000 years ago, 400,000 years ago, but it's wandered into an area of what's called interstellar cirrus, and this infrared cirrus is very, very thin material, but can be dense enough to scatter the light from these hot, youngish stars of the Pleiades. And the next image, I think, shows this rather better. And this is not one of mine, I hasten to add. This is a gorgeous picture, pinched from the internet, showing this lovely, very thin material being illuminated as the Pleiades pass by. Now, why does that happen? Well, they're basically in the same sort of way as the sky is blue. The radiation gets scattered, but the shorter wavelengths tend to be scattered more easily and in all directions. And this is called Rayleigh scattering. And so the blue light predominates. And so when we have a lovely morning like we did this morning with the sun shining from a lovely blue sky, it's because the sun's yellowish radiation or yellow-white radiation is largely being scattered by the atmospheric molecules and atoms in our own atmosphere. But that's not always the case. Sometimes light will fall upon much larger particles, molecules or nanoparticles to microparticles, and the light is scattered in different sort of ways. Now, I'm afraid I don't speak German, but this is sometimes called Maya scattering, and it does vary with particle size. So this is why some reflection nebulae are not blue, and I've got a couple of examples of those here. One is Hines Variable Nebula next to T Tauri. T Tauri is the star here, variable star. The nebula next to it's one of the most fascinating of the variable nebulae, in so much as it was discovered in 1854 from Regent's Park in London, would you Adam and Eve it? And it disappeared over the subsequent decade, only to be eventually caught again at the end of that century. And it's now more stable. It's not been doing anything very much for a while. This is an image by Adam Block with a large telescope in Arizona. And another one which shows that the scattering is not always blue is the Toby Jug Nebula, and this is an emission nebula, not a planetary nebula, but an emission nebula in the southern hemisphere. And this is extremely yellow, but the reason that these two are orangey yellow in colour is because their particles around them are very much bigger than than straightforward hydrogen and smaller atoms. So bigger particle size, different wavelengths do play a part when it comes to reflection nebulae. So I thought I'd have a couple of case studies regarding this. This is one of my very favourite regions. This is the Rho Ophiuchi region. We've already seen the Pipe Nebula and the Dark Horse, and Saturn had moved a bit, I think, yeah. But this is Rho Ophiuchi, and this, of course, is Antares in the Scorpion. And in that area is a marvellous array of reflection nebulosity. I used to have this is a David Malin picture. I used to have it on my wall in the surgery, and everybody admired it except those with the migraine. People with the migraine were not over pleased with it. It's an extraordinary area. This is obviously a very deep image taken with the 48-inch UK Schmidt at Anglo-Australian Observatory, or whatever it's called these days. This is Antares down here. This is Messier 4 globular star cluster, and the only part of this image that is in fact emission nebulosity is here, or just to the right of Sigma Scorpii. The Rho Ophiuchus gives a pretty typical colour to his nebula. The dark area in the middle is what Herschel used to call his hole in the heavens. He thought there was a really starless region that he was exploring there. There are a few stars there, but he thought that might be a hole. But other nebulosity around there is so varied, shows such a variety of colour. It's quite extraordinary. Antares, of course, is white here. We know it's a red supergiant star. But it's so overexposed, it's become white. But you can see surrounding it that it's got a whole range of colours, because, of course, Antares has pumped out a whole load of material over its lifetime, and some of that is reflecting the light from Antares in, and some of the particles are larger than others, and so you get this wide range of material, and indeed spectacular coloration. The other case study is the Trifid Nebula. I always used to call it the Trifid Nebula because my O-level study book, one of them was the Day of the Triffids, but that has got a double F. So that's something I'm going to have to get my head around over the years. Not easy when you get to my age. But this is a wonderful nebula in its own right. Again, very low down, unfortunately, from the UK, minus 23 degrees. But it's worth seeking out if you can. It's same sort of latitude as Saturn and Jupiter at the moment. So if you're getting Saturn and Jupiter, you should be able to get the Trifid Nebula too. Trifid. Sorry, Dave. This is the Lagoon Nebula in a wide field view. And we have Messier 18, a small open star cluster north of it, but this is the target here. And it just has three wonderful, colourful components to it. First of all, it has the the dark lanes, which is Barnard 85. And then it has the emission nebulosity due to a tight cluster of stars, 6 very, very hot stars, HN 40, and they are a mere 400,000 years old. So they're really quite young still. And then surrounding that area, and better shown on a professional photograph, or near as damn it professional photograph, is the whole thing is immersed in reflection due to the star just here, which is HD 164514. Don't expect you to remember that. But the star itself is magnitude 7.5, and it's causing the reflection around the whole of the nebulous area. And of course, this is an area that Hubble Space Telescope has had a look at and has found several evaporating gaseous globules, or eggs, as shown here. Some of these are going to form stars and hopefully planets too. So we get on to old age. This is the other end of the age spectrum, and we have planetary nebulae. Now, planetary nebulae are not quite, they are emission nebulae, but they're not quite the same as the ones I described earlier. These are old stars, sun-like stars, which have gone through their sort of 10 billion year life and have puffing off their outer layers at something called the asymptotic giant branch stage. And they basically then leave the exposed core of the star in the center, which we now call the central star, which is extremely hot body with prodigious amounts of ultraviolet. And this causes the material that has expanded away from the star to be fluoresced. It's still excited material, but it's not all hydrogen. In fact, a lot of it's oxygen, which is why a lot of these are bluey-greeny in colour. And then you have some hydrogen on the outside, which often glows red too. And on the left here, we have the famous Dumbbell Nebula. The right, we have the Ring Nebula. I'm sure most of you are fairly familiar with these very lovely objects. I think they're some of my favourite objects, and dark nebulae are one of my hobby horses, but planetary nebulae got me really heavily into nebulae in general. They show wonderful variety. None of them are very big, and that has been a problem in the past because they were quite difficult to image. But now with the more modern techniques, we can start getting some half-decent images. So you can get a nice colourful Owl Nebula, the Messier 97 in Ursa Major, and this somewhat neglected one in Cepheus, which is circumpolar planetary nebula, which is unusual in so much as it's very red. And this is because it's got very little oxygen in it. It's predominantly hydrogen and nitrogen. So it has a tendency to glow red rather than the traditional greeny blue colour. A couple of more greeny blue ones, really. The couple very well placed at this time of year, NGC 6781 in Aquila and 6905 in Delphinus. These are worth teasing out. They're smallish nebulae. The Delphinus one is only about half about 30 seconds of arc across. The Aquila one is a little larger, but some of them can be really quite challenging. These two, one in Gemini, one in Pegasus, Abell 21 is an extraordinary shape, sometimes known as the Medusa, sort of the serpentine-like locks perhaps. And then Jones 1 in Pegasus is another large, low surface brightness object. So that's great fun too. So star death, the end of the end of the star's life. If it's over about 8 to 10 solar masses, it's likely to explode. Core collapse, particularly likely. And when this happens, the material is ejected forcefully. And we've seen, sadly, we haven't seen one because it's in the southern hemisphere, but the one in our lifetime in 1987A in the Large Magellanic Cloud, we're starting to see the expansion of that quite nicely. Of course, the Crab Nebula went pop in 1054, was seen to do so by people in Korea, China, and that was recorded, and it's perhaps one of the most famous nebulae in the heavens. The one on the left taken actually with a very small telescope, the 70mm star wave, and the other was my TMB in hydrogen alpha. So all sorts of techniques can be brought to bear on supernova remnants. There aren't very many of them. Here's perhaps the best known. This is the Veil Nebula, or part of it. This is the Eastern Veil Nebula, NGC 6995. The other part of it is further to the west, and it also can be nicely imaged, but this is the more spectacular part of it. This was thought to have gone and blown up about 10,000 years ago, so considerably older than the Crab Nebula, but a very beautiful object, I think you'll agree. And a couple of others. This is the so-called Jellyfish Nebula. This is one I'm hoping to get a better image of coming this winter, on the left, and one that's completely eluded me, but I'm delighted that Peter Carson has let me use his image of an enormous supernova remnant called Sumaze 147 on the Auriga Taurus border, and that's about 2 degrees across. It's it's bigger than the Veil Nebula, but much fainter, and it does take quite a bit of teasing out. Sometimes called the Spaghetti Nebula, but I don't know if that's a bit too fanciful. So the Hubble palette, this is not something I'm going to touch on, but it became particularly popular, I think, with this launch of the Eagle Nebula image from the Hubble Space Telescope back in 1995, and they then refined the colours within it for 2014, and it's one of the great iconic images of our time, I think. Now, I don't use that myself, but it is said to bring out all sorts of additional detail, which other photographic techniques doesn't. And it basically, you use narrowband filters, typically hydrogen alpha, oxygen filters and silicon filters, and then put your choice, almost, I think, of color into it. And Nick Shimonek recently imaged the North American Nebula, and you can see that it does give it a completely different sort of feel, because the North American Nebula here predominantly in blue, the Cygnus Wall, I think they call this area here, this yellower area, and then we have the Pelican showing up really quite nicely. But it has a different feel to the more traditional reddish images, but does bring out an extraordinary amount of detail. So I'm going to finish with just conclusions. I think that they are fabulous things they're popular targets, of course, some of the most beautiful things in the heavens. They do represent all stages of stellar life, from the raw materials through birth, old age and death. There's a whole host of different challenges, and I know many of you do love imaging these, and there are the lollipops and they're the more challenging ones. So there's something for everybody, really. And I don't think there's any right or wrong way of processing these things. I mean, I have my own preferences, of course, like most do, but there's no right or wrong. So the important message really here is to go out and enjoy them while you can. So I'll finish there and hand over to Sean, who can talk to you a little bit about his images and the...
Okay.
Yeah, I'm coming out of here. Right. I'll get rid of myself. I hopefully will be here for questions after Sean.
Thanks, Nick.
Okay.
Wonderful
All right,
stuff.
thank you very much. That was good to hear some information about the stuff, what you're doing. That is good. Okay, right. I'll bring up my screen. Hopefully everybody can see that. I think we can. Is that okay?
Yeah, we can see that, Sean.
Okay, mate. All right. Yeah. I just put a couple more in because while you were talking there, I thought I think I've got one of each at least. So I'll start with. I'll just bear with me there. Move this out of the way because I've got a dark nebula, which is, where are we? Here we are. The one that was the faintest thing I've ever done. The Baby Eagle in Taurus. I believe that's a dark nebula, but that took 18 hours to bring that actual shape out. It's about 13 hours of luminance to bring this out. And interestingly, when I first did it, I couldn't see anything, obviously. That took me about half an hour. And then I sort of stretched it, and I just sort of saw this bald patch in the middle with no stars. And that's the only sort of time I realised, well, I must be on the object. So like 18 hours later, I sort of pulled that detail out, which was quite nice to do. So that's I believe that's like a dark nebula. But going on to, well, one of my favourites, as Nick said, is the Reflection Nebula. I mean, I'm not necessarily in the order of how they work, but one of my favourite ones is, if I can find it here, I know what they all are, I've just got to see the names, which is NGC 1333. There it is. This one. That's one, a personal sort of favourite of mine. I just think that's, it's lovely. It's got so many colours. I think it's got a lot of brown dwarf stars. Nick will probably know, but the colours that the reflecting stars that give off that kind of colour. And I say it's all in RGB, so it's kind of more difficult to capture really. But that's one of the better reflection ones, I'd say, with most colour in the Northern Hemisphere. But moving on to let's see. Well, there's plenty some bicolour images here. I don't know if Nick, if you mentioned this, but this was done over a year. I think I spent one winter doing the bottom half, and then I didn't have time to get the second half because that's a panoramic of 2 panes. I got the top half the following year, but that's hydrogen alpha and oxygen. And what I do with them is make a synthetic green. So I mix the two up to make a green. Because that predominantly the hydrogen is in the red, because that's put in the red filter with the oxygen in the blue. But that was a lovely. I do like the sort of the bicolours. They come out very nice. Let's see, a couple of more sort of classic, or going on to the emission nebula, which is my favourite. And obviously that's the Elephant's Trunk, IC 1396. And I tend to do about 5 hours each in each filter. And as Nick's saying, hydrogen alpha and oxygen and sulfur are the filters, but it's just that the way they're put into the Hubble palette is that the hydrogen is put into the green, and the sulfur in the red, and the oxygen in the blue. And that was just, I mean, this was sort of devised by Hubble, but it gives the most pleasing sort of effect, So you kind of use, sometimes you don't get a lot in the sulfur on quite a few images, and obviously you get loads of hydrogen alpha, which you don't need necessarily, because that's used as just a green to sort of balance it up. But sometimes I'll mix and put sort of some hydrogen into sulfur just to sort of bring up the colours. But as Nick said, I mean, the amount of detail you can get in these is amazing, because these filters are not 5 nanometers of wavelength, so they're cutting out everything, any sort of amount of street lighting or anything else. So you're getting the pure detail of the nebula. Another one that I find, I quite like is Gamma Cygni, because it's just, the colours are so, there's so many colours in them. And again, it's the same thing, it's a Hubble palette, but they all look slightly different depending on what's in there. But there's a lot of stuff going on in that one, and all these dark lanes. But the colours, the colours are really good. Another one, let's see what we've got. Oh, you mentioned the jellyfish, didn't you? That was one I did about a year ago. And that was, that's you can see the sort of oxygen, can't you, sort of bouncing forward and the tail there and some out there. But I think that was in 2018. I literally had 5 or 6 nights on the trot, and I got 5 hours every night. So that's a 30-hour exposure in total. So, I spent each night doing one filter. And by the 7th night, I was exhausted. I've never been so pleased to see the clouds. But that was nice. That's a lovely object. But again, that's a 2-panel mosaic. but that shows up, you know, nicely. It's just a lovely object to do with the Hubble palette. It's one of the classic ones. Let's see. Oh, I've got going back to a couple of reflections on bouncing between them. But that's the good old Iris Nebula in is that Cepheus? I think it is 7023. But yeah, and that's really, I mean, that's just dust being reflected by that huge star or that series of stars in there. But again, LRGB, and in a way they're more challenging because you've got light pollution and what have you. But they're more satisfying to try and get the details out, especially the dusty areas, to pull that kind of dust out from the background. That's the kind of thing that I like doing. But typically, I'd do about 5 hours, I think, of luminance with them, and about 90 minutes of colour, you know, in red, green, and blue. But the luminance obviously gives the detail. The luminance is like the sort of, like the brush strokes, and the colour is just the water colour, you know, so it's not like detail of the colour, but there isn't luminance. Another one was, so I did that as a reflection, M78. You know, I get an awful lot of colour in that, but that was another reflection there. But I think that's an emission in there as well. If I think so anyway. New and improved. Right, Pelican. There's a 2-panel. I got that last year. But that's a brilliant one. I mean, I'd like to do that. I'd like to get the sulfur this year because that's a bicolour. So that's hydrogen and oxygen with a synthetic green. But the shape of it is just great. But in the Hubble palette, I mean, that top area that glows in that sort of sulfur kind of brown golden colour, and it looks really nice. So hopefully I'll get that this year if we get sort of enough nights, because I'd need about another 10 hours because I do about 5 in each. But we'll see how it goes this year. Let's see. Go down to this one. There we go. I knew I had one from way back. I thought I'd try and get them all in. That's the Planetary Nebula, obviously. I think we got that from, that's my friend who captured that, and I processed one. But we captured that in Scotland in very dark skies. But that was LRGB, so there weren't any hydrogen or anything like that in there. But that'd be interesting to do with that, because you can get a lot more detail in it. But that's just one that I got then. Supernova. Yeah, that's obviously the Veil, the Witch's Broom. And again, I think that was bicolour because there's so much oxygen in that, as you can see. So there's a good bit of hydrogen, good bit of oxygen. Mix them up, the two of them, to make a synthetic green. But yeah, that's. I'm actually working on the Eastern Veil this year because that would actually kind of fill my field of view, and that's a lovely part of the Veil. It really is, as you know. A favourite, another one was from last year, the Wizard Nebula. Again, the Hubble palette. About 5 hours in each filter, and I think I might have mixed in a little hydrogen just to sort of tweak up the sulfur, just to bring some more detail around that golden, you know, base there. But you can see the oxygen in the center, and you know, the lovely structure of it. That's what I love about this narrowband. It gives you such good detail, good structure. Here's my favourite. This is my longest exposure. Good old Rosette. I spent an awful long time on that one. In fact, I normally do about 5 hours in each filter, but this one, I don't know why, I did 10 hours. And those extra 5 hours really did help because it virtually processed itself. You know, you kind of put it in there, there's no noise whatsoever. And I contemplated getting the whole thing in, but I'd need a 4-panel mosaic, which would have taken like 120 hours or something. So with our skies, I kind of gave up on that idea. But yeah, I mean, and I also put in some RGB stars, because sometimes the hydrogen alpha kind of dominates in the stars, so you'll end up with quite a few little red stars, which you might not pick up in the oxygen. So I did some RGB and then just overlaid them and put them in. But, you
can see the donkey and the cheetah quite nicely in there.
Yeah. Again, I mean, this is the selective processing what I mentioned on Saturday. You know, with sort of just tweaking out, but not overdoing it. But yeah, the dark lanes in there just are so intricate, isn't it? There's so many things going on in there. You know, and it actually looks, you know, you can give it a 3-dimensional look if you kind of sharpen areas and blur things and stuff like that. And that's the creative part. That's what I like doing. But you can, they come up nice, don't they? But and those bright O stars, are they? Did you say OB stars? Yeah. What we got?
The O star there.
Horsehead. There we go. We'll leave it with that one. That is obviously the Horsehead, but this one, unlike a lot of people, that's lovely invisible colour, but I thought I'd do it in the Hubble as well. And I think, I mean, that's quite relatively short for me, because that was 4 hours of sulfur and 2.5 each of oxygen and sulfur, and H alpha, sorry. But again, I mean, the colour and detail it just brings out is great, you know. And I only had about 90 minutes per session, because it literally just traverses my my shed, my garage. So I get about an hour and a half, and my neighbour's roof. So it's kind of, that's why I kind of did it in the Hubble. But again, it shows a lovely detail up here, you know, and them sort of fanning out there, and obviously the horse's head, but also the flame. But yeah, I mean, again, I would say it's about a 10-hour exposure. I think, yeah, I think that's about it. I think. Yeah, I think that's about it. Yeah. Well, I mean, I've done a few more than this, but I just thought I'd try and get a selection. You know, reflection, planetary, supernova, and the lovely emission, like I said. But the emission nebula is the favourite, I think, for all images, because usually getting narrowband just cuts out all that light pollution, and you know, you can really concentrate. I mean, I do 15-minute exposures, and they're 5 nanometers of wavelength. They're astral filters, so they're really good, you know, and just gives you detail. The detail's phenomenal. But yeah, but that's my little selection. So,
brilliant. Thanks so much, Sean.
No worries, no worries. Yeah,
fantastic images.
Thank you very much.
Any questions for Sean or Nick?
Just a comment, actually. I think Sean's images are absolutely fantastic. I did know that would be the case, but the Hubble palette brings out a 3D feel to it.
Yeah.
The RGB does, and particularly that whole was just 3D, wasn't it? I mean,
yeah,
sitting out.
It does. It's funny. Like when I showed the bicolor, let's say, you know, I mean, it's lovely. It's really nice, but the difference between that and a Hubble is exactly that. You've got the two filters there with the synthetic green, but somehow the Hubble, as you said, like the horse head, it does that sulfur, brings in that 3D. It just totally changed it, you know, which is surprising, because I mean, and there's a lot of stuff there where there is not a lot of sulfur in there. But actually, one of the ones I didn't put in was the Heart Nebula, and that's, I think, the Heart was one of the ones that had probably the most sulfur in it, because there's not many that do. But once you add that in, it really brings in that 3-dimensional look to it. You know, the 3 filters. Yeah.
That's one of the best images of the horse head that I've seen, Sean, if I may say so. I love the colours on it.
Thank you. Oh, thanks very much. Yeah, I sort of warmed that one up a little bit, but thanks. Yeah, it's you know, you try and do your best, don't you? It's hard. You try not to overdo, you know, and I have been known to overdo a little bit, but yeah, you know, it's nice to get the detail in the cloud, and because Hubble, you know, allows you to do that. You do get more of that 3D effect, as you say, because you know, there's more clarity to it. That it's not a broad band of light. It's a very narrow band. Of course, that's where it's all happening. So, you know, you can really sort of bring it out.
Looks more like the big bad wolf than a horse head now, doesn't it?
I've seen one with an actual horse's head. I can't think where, but there was one there. There's one online somewhere, and I swear there's a horse's head. Yeah, an actual horse. I've seen it. Yeah. But it's. I mean, when you look back over the winter, I think I said to someone, you know, you can't believe. You think, well, I've got no time in this year. The weather's been rubbish. And you go back through the year, and you look through the images you've got, and you tot up the hours you've done, and before you know it, there's like 300, 400, 500 hours. You know, but of course, you know, having I've got a little roll-off roof shed, and having that enables you to go out for like 90 minutes if you've got a clear spell, you know. So, and I've had many nights in December where, I mean, some nights I've been starting at 5:15 and going until 6 in the morning. So, because it gets that clear, you just think, well, I can't put it down. That's too good. You don't get enough nights to do it. So, you know, I've had time out there, that's for sure. But, yeah.
Puts my hour or two for an image really to shame.
Oh, right. Well, that's why they take a lot more. People say, you know, well, you haven't done an image. Well, no, but they take a few months. Some of them. I mean, I've started on the Eastern Veil, but you know, I've got about 2 hours maybe in one filter. So I was trying to get them before they disappear. You see.
Yeah.
Yeah. There you go.
Sure.
I love doing it. So.
Fantastic. Absolutely amazing.
Cheers, mate.
Thank you very much.
Welcome. Yep.
Excellent. Okay, any other questions from anybody?
Yeah, actually, Dave, yeah, I've got a question, if that's okay. Sean, fantastic images, absolutely
Thanks.
astonishing.
Thank you.
Unfortunately, I wasn't able to make the presentation you did a few days ago.
Right.
It just fell at a really inconvenient time for me. So I'm interested, you're showing them all in Photoshop here. Do you actually do all the post-processing with Photoshop? Or do
Yeah, I'm a Photoshop man. That's all I've ever used. I've got Maxim, so I do some pre-processing. I do some DDP, you know, to sort of bring the dynamic range down. A bit of flatten in the background, and then it comes into Photoshop. And I've been using that for years. And yeah, I can see the beauty of that is you can do a deep sky image, then you can turn around and make a calendar up with it. So,
yeah,
you know, it's just, I've invested so much time in it. You know, I wouldn't really consider, you know, doing anything else now because I just invested hundreds of hours in it.
Yeah.
But yeah.
That's brilliant.
Yeah.
Thank you.
Yeah. Oh, yeah.
Okay. Any others?
I hope this isn't too simplistic, but my understanding is that heavier elements such as sulfur and oxygen are produced in a nuclear furnace. Are all these nebulae long-term effects of supernova?
No, the emission, I mean, I think they're pre-star formation, or that's when the stars are in formation. So I understand. So, you know, that's why you get, like, in the rosette, where are we, the rosette? I'll find it in a minute. In the rosette, you've got these dark lanes and what have you, and apparently, I believe that these are the areas that are, you know, the most dense, you know, and with the most heat that are forming stars. I think the elephant's trunk is probably the one.
Yeah, they're the hot globules, yeah.
Yeah. There we go. Because there's apparently 200 or 300 stars being formed, you know, in that area because it's so dark you can't see through it, and that's where, you know, that's where they're being formed, like a star factory kind of thing. So that's as I understand, Mission Nebula is that stage.
But is that a second generation star?
I don't know. I think what we're up to about a third generation by now. I think I think the Sun is a third generation.
Yeah,
So
I think most of the universe has been seeded with supernova remnant material, hasn't it? So
yeah.
Right.
So they're all at least second or third, you know, generation stars now. Yeah, because of the heavier elements that are thrown into the mix. You know.
Thank you.
You're welcome. Yeah.
Can I ask a simplistic sort of question?
They're my favourites. Go on.
The Hubble palette you were saying about.
Yeah.
Is that the filters you're referring to, or?
That is the filters, and that's the way the filters are put together and colorized. So, you know, as I say, you've got hydrogen, oxygen, and sulfur, you know, which are the three filters used in the Hubble palette. But it's the way they're actually, because they're in black and white. They're black and white images essentially, but they're in very narrow wavelengths of light. So you actually colorize them. And the Hubble palette happens to be the hydrogen is green, the oxygen is blue, and the sulfur is red. And that makes it, that gives it that kind of look, that blue and goldy brown. There is another method, I can't remember what it's called, but it just looks it looks awful. Yeah, if you mix them in a different way, they just don't look good.
Well, what is the real colour?
Well, these are what they call false colour because you know, the sulphur's up the high end of the red spectrum, isn't it? And the hydrogen is still in the red part of the spectrum, and I think the oxygen is just between the green and blue. But I wouldn't make a red, green, and blue image. I wouldn't give all the colours. So they shift them around to give it, you know, the full sort of tonal range in colour.
and then if you wanted to, you could change it yourself again anyway. So you know,
yeah,
you want to be artistic about it.
Absolutely.
Yeah.
Yeah, you can try out. There is, as I say, was there one called Hawaii? I've seen one before where there's a different mix where they don't do it as in red, green, and blue with using the hydrogen oxygen. They mix them, and that looks horrible. In my opinion, anyway. But
it's the cyan, magenta, I think, isn't it?
That's more for printing, isn't it? Use cyan colour.
Yeah. I think if you look online, I'm sure it's called a Hawaiian Nebula or something like that. They just, instead of colorising, you know, H alpha green, that might have been coloured red and the other one green. Do you know what I mean? I can't remember now, but I've seen it way back, but you know, it just didn't look right. There's nothing like, this. This is the prettiest way, in my opinion. I mean, those golden browns and blues really make them stand out. To give that, like you say, that 3D look. But yeah.
So you sort of do like hours on a certain filter, and then another hour on a different filter, do you? Quite
literally, yeah. I mean, so I do 15-minute exposures, and typically I'll do 5 hours or so on each filter. So obviously, you're not always lucky enough to get it in one night, but that might take 2 or 3 nights to get one filter, and so on and so on. Some of them take longer because you know what the weather's like. But that's what I like doing. That doesn't bother me. I'm not after, I don't want to get it. I'm not bothered about getting it in an hour. I want to get the detail, as much as I can, really. But I tend to find that 5 hours is about the right amount. Really sort of starts to bring out that look that I'm looking for.
Shows the old adage that hard work really does pay dividends.
Yeah, that's what they're saying. That people, when people say to me, "You must be so patient," my wife sort of roll her eyes and go, "Yeah, I am with this. I am. This is my golf." You know what I mean? You sit out there at night, and lovely. Yeah, that's great. Lovely.
Fantastic.
Your telescope must be set up perfectly, is it?
Sorry.
Your telescope must be set up perfectly to.
Well, I mean, I'm lucky to have a permanent rig, so it's on a pier, and I've only got a polar line once, that's done. Do each thing once, that's done. So all I've got to do is literally go in there, unlock, sort of roll the roof back, fire it up, get it connected, and I'm ready to go. So yeah, and it's on a very solid pier, that full of sand and all the rest of it. That's as solid as I mean, it's quite a heavy pier that is. But yeah, so it's ready to go.
Yeah, that's good.
It's 10 minutes. Yeah,
right.
I'm far too lazy. I don't think I'd have ever done what some people do when they get it all out and set it all up. I thought no, but that allows you to get more time. As much time as you possibly can out of it, really, I suppose. Yeah.
Not lazy, Sean. It's a preferred option. It's just that not everybody can do preferred options.
No, well, this is it. And I know. I mean, I'm lucky. I'm very lucky. I got to this place, and the skies are pretty good, and they turn the street lights out. So But what I did do, I looked around the sky, and as I said to you, the lowest I can get would be probably the Horsehead. Maybe I could get Orion. But when I set things up, you've got to go for the best that you can do and give up on, not try and do the impossible. So at the time, I could have moved my shed further across, but the leads would have been underground. There would have been so much. I thought, no, I'll get a good 3/4 of the sky there. So I gave up on the lower southern objects, but I managed to do all right with it. So it paid off, really.
You're not doing too bad with some of these images. I'm most impressed with them. They appeal to me.
Oh, thanks.
If you haven't looked yet, folks, check the link in the chat.
Yeah, that's the website. I spent a lot of my life, last 10 or 11 years, being nocturnal. Yeah.
Brilliant. Yeah. Well, thank you very much, Nick, for telling us all about nebulae. So if there's no other questions for Nick, no, great insight into what makes nebulae tick and why they're there, etc., etc. And Sean, absolutely wonderful images again.
Cheers, mate.
Outstanding.
Cheers.
So fantastic. So I suppose what's time you? Ooh.
Fabulous double act. You should take it on the road.
Exactly. Yeah. Brilliant. Well, thanks so much, everybody, for coming along, and thanks to our two speakers, Nick and Sean. Absolutely brilliant. So you know what I'm going to say.
Right, I'm going to head off to the other meeting.
Okay. Have a good meeting, Nick. So
thanks.
Yeah.
Bye.
Bye.
Keep safe. Keep well, and
keep
looking up. Cheers, folks.
Cheers.
Bye-bye.
Cheers. Bye.